Okay, we are now ready. We already just got done doing quadratics, solving quadratics by graphing, which of course isn't that much fun. But now we're going to solve quadratics by factoring. Okay, all the way back to chapter 7 where we factored a trinomial, a quadratic trinomial, and we factored it. Remember Daniel's method? Go back to chapter 7 and all the 7 slides if you don't. So a little review of factoring. You can have x squared plus bx plus c and y equals ax squared plus bx plus c. So you factor it. We'll go pretend you have factored it and you now have your binomials. Your zero product property means make y equal to 0. So here are let's say this is my factoring of a quadratic trinomial. X minus 3 times x plus 7 equals 0. That means that either one of these binomials or both of them are 0. So x can be either 3, because 3 minus 3 would be 0, so the whole thing is 0. Or x could be negative 7. It could be either one, and this entire product here is going to be 0. If even one factor is 0, the whole thing is 0. Example, x times x plus 4 equals 0. My zeros are either 0, because this x is just a 0, or negative 4. There are 2 solutions or 2 zeros. So if I'm getting 2 answers the same way I did here with 3 and negative 7, I have 2 solutions, 2 zeros. Negative 4, positive 3, 2 zeros. This is real simple, but we all know that the hard part was factoring. So depending upon whether you want to factor that trinomial or not, then it makes finding the zeros very easy. If an equation is written in standard form, ax squared plus bx plus c, you may need to factor it before using the 0 property. Y becomes 0. So I have my original formula. I factor it. I now know that either x plus 2 is 0 or x plus 5 is 0. My solution's negative 2 or negative 5. Take those solutions, put them back in the original formulas, and make sure that you get equal sides. As long as that happens, you have found your solutions, your zeros. That was the same with graphing. Once you found your zeros, you have to put them back into the original equation and test that both sides equal. Excess of symmetry. That is the average of the zeros. So if I know my zeros, I can take their average and find the axis of symmetry, because the axis of symmetry goes right through the center. So it makes sense. So I take my 2 zeros, average them like any mean you would do, an average, and I have an axis of symmetry as negative 3.5. Oh, all of a sudden things are looking a little easier. The whole problem was factoring. You can now calculate for a y value from the original equation to calculate the vertex of the parabola. So I'm going to have my axis of symmetry and I'm going to have my vertex. And we all know that the vertex is going to have the x value of the axis of symmetry. All I needed was the y value. So example, x squared plus 2x plus 1 equals 0. Factor it. X plus 1 times x plus 1. X is just going to be negative 1, isn't it? I have x plus 1 equals 0 or x plus 1 equals 0, because this really is a squared factor. This is x plus 1 squared, isn't it? X equals negative 1 or negative 1. That's the same number, everybody. We all can see that. There is only one solution, -1. If you only have one solution, and that becomes your axis of symmetry, does that mean your vertex is also there? One solution. I go ahead and I factor these equations. -2, don't worry about this -2 because -2 is never going to equal 0. That means the x minus 3 has to equal 0. So my solution is 3. X equals 3. Since -2 will never equal 0, there is only one solution, x equals 3. When there is only one solution, that solution becomes the vertex, 3, 0. So not only was it your axis of symmetry, but it was also your vertex. In summary, if there are two solutions, you find their average to calculate the axis of symmetry. Use this x value from the axis of symmetry to substitute it into the original equation to solve for the y value of the vertex. If there's only one solution, that is the x value of your vertex. It also means the vertex is on the x-axis and y equals 0. So your vertex is the x you calculated, 0. What if there's no solution and no 0? 2x squared plus 6x equals -18. Okay, first of all, I have to make it equal to 0. I need to move the -18 over, so I add 18 to both sides. Now I make my y 0, or this is automatically going to be a 0. I start factoring. Is there a way to factor? If there is no way to factor this trinomial, then I do not have a 0. There is no solution. Does that mean I don't have a parabola? No. It means that my parabola never crosses the x-axis. So when there is no solution, it just means the parabola never crosses the x-axis. Okay? That's it. We are done for this week, and I will be back next week in order to show you the shortcut, finally, the discriminant and the quadratic equation. And you're going to go, why did you have to wait so long? But you did. Knowing how to do things without a calculator and without remembering a formula is important. Enjoy. Thanks for watching.